K8BYP's video on the cold neutralization myth. There's a happy myth that we can neutralize an unpowered amplifier by putting a signal on the grid of the tube or tubes and tuning the neutralization capacitor for minimum output. That's nonsense, and here's why. The purpose of neutralization is that in an operating amplifier, there's for example, a triode here, and there's a feedback capacitance called C sub M, or Miller capacitance. The Miller capacitance feeds energy from the plate back to the grid, and one text says that as a result of inductance in the tube pins and leads, this can find a resonant circuit and lead to oscillation. The purpose of neutralization is to feed energy back in the Drake TR3s and 4s, actually back to the driver stage before this, out of phase, so that hopefully it cancels the capacitance fed from plate to grid. Miller capacitance is defined as when the tube is operating with a certain gain. Miller capacitance, or C sub M, is C sub P to G, which is with the tube off, the internal parasitic capacitance from the plate to the grid in the tube. So this C sub PG is inside the tube. When a tube is operating, that capacitance is multiplied by a factor of A plus 1, where A is a voltage gain, and that's related to transconductance. And to find voltage gain, either consult the data sheet, it may give a voltage gain figure, or look on the plate curves and calculate the voltage gain. It may be something like 20 to 60. So we can see that if the gain is 60, then the capacitance from plate to grid is multiplied by 61. That's a big change, and a big change in coupling from the plate to the grid. The cold myth assumes that we can just feed signal from the grid here and measure here, and somehow that magically gives neutralization. But it doesn't, because the real capacitance that causes oscillation is 60 times higher than that. So this is not accomplishing neutralization. One might calculate the Miller capacitance and externally put that from plate to grid in a cold circuit and maybe give it a try. I've not tried it, I've not calculated it. Good luck. Another way to approach this might be to use a general coverage receiver, such as Yaesu 857, which will tune from 136 to 164 megahertz, or maybe the mighty Baofeng down there at the end of the bench, which will tune from 136 to a gigahertz, and simply scan up through the VHF range and find the parasitic oscillation frequency. There might be some energy there, maybe bump the neutralization capacitor a little bit out of alignment to find it, but it's going to be there. And maybe lay a piece of wire up across the chassis or near the amplifier enclosure and couple energy in and listen for it, and then tune the neutralizing capacitor for minimum or no energy. But beware, these parasitic oscillations in this TR3 were strong enough, and I literally sat and watched this happen, that one of the suppressor resistors on one of the plates, in fact it was a front tube, V9, it got warts on it. That's a sign of extreme overheating. When a resistor gets little bubbles up of warts on the surface, it's getting very hot. That's a 2-watt resistor. So, assuming there are 3 suppressors, that parasitic energy might be dissipating, or the parasitic suppressors might be dissipating several watts, maybe 6 watts. That's a lot of power at VHF. So that's why it's necessary to neutralize, cuts on spurious emissions. So also note that there are 3 amplifier tubes in this radio. The neutralization control does not necessarily have the same effect on all 3, because the front tube in this radio here tunes differently. The the suppressor resistor on the front tube runs a little warmer than the rest, that indicates that that tube is having a bit of parasitic emission. So it probably has a bit different Miller capacitance, maybe a little different gain. So there's the skinny on neutralization. 7.3 from KBYP.